Chi-squared goodness of fit test in Python, way too low p-values, but the fitting function is correct. Despite having searched for 2 days in related questions, I have not really found an answer to this problem yet. In the following code, I generate n normally distributed random variables, which are then represented in a histogram. After that, a curve-fitting function and its parameters are found. It is normally distributed with the parameters a1 and b1, and scaled with scaling underscore factor to meet the fact that the sample is unnormalized. It indeed fits the histogram quite well. Here's the plot of the histogram with the fitting function in red. After that, I want to test how well this function fits the histogram using the chi-squared test. This test uses the observed values and the expected values in those points. To calculate the expected values, I first calculate the location of the middle of each bin. This information is contained in the array x_middle. I then calculate the value of the fitting function at the middle point of each bin, which gives the expected underscore value array. Plugging this into the chi-square function of scipy, I get p-values of approximately e5 to e15 order of magnitude, which tells me the fitting function does not describe the histogram. But this is not true, the function fits the histogram very well. Does anybody know where I made a mistake? Thanks a lot, Charles. P.S. I set the number of delta degrees of freedom to 2, because the two parameters a1 and b1 are estimated from the sample. I tried using other DOF, but the results were still as poor.
Your calculation of the endpoint of the array x_middle is off by 1, it should be. Note the extra 1 in the second argument of linspace. A more concise version is. A different, and possibly more accurate, approach to computing expected underscore values is to use the differences of the CDF, instead of approximating those differences using the PDF in the middle of each interval. With that calculation, I get the following result from the chi-squared test.